Hi everyone, today we are going to start talking about ellipses, which is our next conic section. The definition of ellipse is a set of all points x, y in a plane where the sum of whose distances from two distinct points called the foci is a constant. Okay, so if you look at this picture here, we have these 2 points that are called focus points, plural foci. Imagine those are like thumbtacks on my board, and I have a piece of string just kind of like loosely hanging from the 2 thumbtacks. If I made that string tight with my pencil and I came up here, so this is the whole string now, if I allowed that string to just kind of do what it would do, I would sketch this perfect ellipse. And that's what all those points x, y are going to be formed from. The set of all points x, y. The distance is going to be set. This string's length is never going to change. The length from here to here on each point might be different, but that string in total is always going to be the same string. It's going to be the same length. So that is how technically an ellipse is created. We have 2 equations for the standard form of an ellipse, and these 2 equations are going to determine the shape or the way you're going to sketch your ellipse. You can see common variables that you're used to seeing. There's h, k in each one. H and k goes with x respectively and y respectively, and hk will be the center of your ellipse. Then you have denominators. Ellipses are formed by rationals, and you notice in this equation both fractions are added together. That's very important, especially when we start to talk about hyperbolas. The a squared and the b squared jump places. So this number in the denominator is going to help you to shape your ellipse. When a squared, which is always going to be the larger number, a squared is going to be the larger number, see it says that down here, is underneath the x. That means it's going to be longer in this direction, and so it's going to have a major horizontal axis. It means it's going to look more like this. I call this one a football. Can't write it. Because it reminds me of what like a football would look like just laying there on the ground. And when a squared jumps underneath the y terms, that means that it's longer in the y direction, so its major axis is vertical. And this makes me think of an Easter egg that you would draw when you were younger and decorate it and do whatever. It looks like an egg standing on its end. So I will refer to these shapes as the football or the egg. All right, so here again, it's showing you the equations of the football and the egg. Eccentricity is a word that we use to describe the shape of the ellipse. So your eccentricity is going to be variable c and a divided by each other. Now, if this ratio is closer to 0, what you actually have is a circle. So the more circular you have shape you have, the closer your eccentricity is to 0. Now, if it's closer to 1, it's going to be looking like a very flat ellipse. So somewhere in the middle would look more like just a nice rounded ellipse. Here's where your eccentricity is going to be very small, equal to 0. All right, so as we start graphing these, you're going to get an idea for what's going on. To take a look, these are the questions that I'm always going to ask you about ellipses. The first question is always going to be, well, where's the center? Since there are no h and k in this one, you can probably guess that our center is considered to be 0, 0. Then you're going to go and you're going to look for your variables a, b, and c. A and b are always given in the problem. And remember, a is always your biggest number in the denominator. So a squared is going to be 25, so that makes a equal to 5. The other denominator is automatically b, so b is equal to 4. And c, and this was back on some of the other slides, I just didn't mention it, c comes from a little equation of c squared equals a squared minus b squared. Kind of reminds you of the Pythagorean theorem. I remember since this is a plus, in a squared minus b squared, it's a minus, it's opposite sign. So to solve for c, we are going to take a squared minus b squared, and 25 minus 16 is 9, and that's equal to c squared, so you're going to take the square root, and so we just found c to be equal to 3, a Pythagorean triple. All right, so now moving on with what we know. Our vertices are going to come from a and b, and since A is underneath X, in the X direction, we're going to go out 5 units. And technically, we call these our major vertices because they're longer. So our first set of vertices are plus or minus 5, 0. Our B vertices are going to be under the y variable, so we're going to go in the y direction, up and down 4 units from center. And so our minor vertices are 0 plus or minus 4. And then these points you can technically use to kind of shape your ellipse. So this ellipse, to me, looks more like a football because it's a little bit more longer in the x direction. Technically, the way we're drawing it, we don't need these focus points, but remember, they're there by definition, so we need to come up with the foci. The foci are the letters or the variable 3, and it's always going to go in the same direction as A. So since our A values went out this way, our foci are out 3 and 3 in this direction. So these would be our thumbtacks that we would put the string attached to draw the ellipse over here. So these are plus or minus 3, 0. And then we just talked about the eccentricity. That's a little bit ratio of C over A. So our C value is 3, our A value is 5. This is 0.6. So our eccentricity is about 0.6. It's kind of right in the middle. It's not looking very circular. It's a little more elliptical. It's a little flatter than it would be a circle. Next one, you can see that now we have a different center. Our center is HK. H always goes with X. So this is the opposite of H and the opposite of K. Oh, I'm trying to write K and I need to write 5. So our center is at -3, +5. There it is. We're automatically going to figure out A, B, and C because we're going to need them for the rest. A is always your bigger number. The bigger number over here has moved to be under the Y's. Our B value is 4, and if we take C squared minus equals A squared minus B squared, again, it's the same numbers as the last problem, so that's 3. This time, I like to look at C where the bigger number is. The bigger number is underneath the Y, so that means in our Y direction, we're going to be going up or down 5. So if we go up 5, we'll end up here. If we go down 5, we end up here. Those points are -3, 10 and -3, 0. Those are your major vertices. Your minor vertices are going to go out this way in your x direction, and that value is going to be 4. So we're going to go out 4 this way. We're going to go out 4, 1, 2, 3, 4 this way. And so those two ordered pairs would be -7, 5, and 1, 5. Our focus points are always going to lie on the same axis as our major vertices. So we're going to go up 3 and down 3 from our center. And so those points would be -3, 2 and -3, 7. And our eccentricity is the exact same as the last problem because we have the same C and we have the same A. So this is at about 0.6. And if we draw our ellipse, we could have done it a long time ago because we knew these major and minor vertices a long time ago. Just kind of do the best you can to hit those points. There's what your egg-shaped ellipse would look like now. Okay, this next one, take a look here. First of all, you see H and K. H is 0, K is -1. But when you go to figure out A, B, and C, A and B are the same number. Actually, that's not even right because I forgot to take the square root of them. They are 2/3. So, excuse me while I fix this. This is 2/3 and this is 2/3. Okay, so this time it's not technically an ellipse. It's a type of an ellipse. It has a radius of 2/3. This is also known as a circle. So you would put your point at 0, -1. And this is a teeny tiny little circle. You would just sort of go out 2/3 of the way away from around all of that. But if you went and you solve for C, C squared equals A squared minus B squared. Well, A squared and B squared are the same. So C squared is equal to 0. So C is 0. So when you go do C over A, you get 0 over 2/3, which is 0. So that's what makes it perfectly a circle. Next one. Ooh, look at this equation. This equation is known as general form, and we need it in our nice standard form that we've been used to seeing. So we are going to have to do that, and hopefully you guessed it. Yes, we are going to have to complete the square. So your job is to complete the square with this equation. And I'm already looking at my timer, and it looks like I am going to run out of time on our notes. So I'm going to have to make 2 videos. I apologize. We'll try to complete the square here. The first step, get all the x's together. Just kind of group your equation so the x's are together. Get the y's together. They can be on the same side of the equation. And I'm going to take that 4 guy to the other side. Next step with completing the square, we never complete the square with a number in the leading coefficient position. So I'm going to take out the 9 and I'm going to take out the 4 and we're going to get ready to complete the square. So this is going to be x squared plus 4x and this is going to be y squared minus 2y. Now we complete the square. Take half of your middle term, which is 2, square it, and that's what goes here. But then you got to balance the equation. So we're not just going to add what number we put here. Technically, there's a 9 sitting out in front. So we have to put 9 times 4 or 36 over there. Take half of your middle term, which is 1, square it, and same deal here. We're going to have to add a 4 over to this side. The reason why we completed the square is now because these are nice, perfect square trinomials. So they factor nicely. So this is going to give me x plus 2 quantity squared. This is going to give me y minus 1 quantity squared. And 36 plus 4 is 40, plus 4 more is 44. Did I do that right? I'm hoping I did that right. Oh, I know where my mistake is. When I moved the 4 to the other side, I forgot this is minus. Okay, that's better. So this isn't actually even 40. This is 36. I apologize. Okay, he doesn't want to erase very nicely. So this is 36. Now to get it in that nice fraction form, we are going to divide everything through by 36. So our equation that we're going to look at for this problem right here is actually going to be x plus 2 quantity squared over 4 plus y minus 1 quantity squared over 9 equals 1. It's really important to get an equal 1 for our conics. Okay, I am running low on time, so I'm going to stop right here and pick up with a second video. You might want to be working ahead and trying to graph this. So I'll catch back up with you.